All right. Hello, everyone. This is the second episode of Interrupt Live. I'm actually here with Steve, who has written one of our more recent articles on Interrupt. And it is about him and his endeavors. We're going to hear more about it, but finding a bug, maybe a bug, hopefully, we think it's a bug, in the ESP32 C++ standard library implementation on sleep. So that should be really fun. We're going to dive into some of the technical bits, some of the reasons how we got into it, and also why and how Steve is using C++ with embedded. But the first thing I want to do is, Steve, go ahead and introduce yourself. What have you been up to in the firmware space? Maybe very quickly how you got into it and what you're working on most recently.
Sure. Yeah. Well, thanks for having me on, Tyler. Appreciate it. It should be fun. So I'm an embedded systems engineer, I guess for almost 20 years now. So I've had quite a broad amount of experience. Everything, when I first started, I was working on 8 and 16-bit chips that had very small amounts of memory. Everything was statically allocated. We were measuring interrupt timing with an oscilloscope, making sure everything was perfect, that kind of stuff. And there was a lot of
timing was important.
Timing was important then. That was back in the day when things mattered. Yeah. So I was able to get into that straight from a standard computer science degree. So I went from 2003, 2004 programming Java to the most low-level C you can go, and then worked up through a lot of Cortex M4, M7, the 32-bit world, and did all sorts of cool stuff, secure bootloaders, cryptography, all sorts of other things, and got to work on embedded Android and the application or APU space. And right now, doing a lot of work on ESP32 and consumer IoT space, which is really cool. And did a lot of work now in C++. And I have definitely a tremendous amount of war stories of all the things I've learned, but it is interesting. I went from the lowest, kind of working myself back up. Now that these new MCUs have hundreds of megahertz of processing power,
yes,
and L1 caching, and
hundreds of kilobytes of RAM. So,
and then the ESP32 has a big amount of external RAM that you can put on there. So you can do a lot of more interesting stuff, right?
Yeah, I don't really talk to too many people who use C++ on embedded as well. Yeah. Let's start talking about this post. So can you give us a very quick intro on what the post is and why you wrote it and what you wrote?
Sure. Yeah. So very interesting thing happened when I upgraded our project to the newest version of the ESP IDF, which is the SDK for expressive chips. Things didn't continue to work as expected, and first thing you notice is if you have an LED blinking or something like that, it was not blinking at the right rate. So started digging into it, and
you literally could actually tell visually that it wasn't blinking. Okay, got it.
Literally, because the CPU there's two CPUs on the ESP32, but one of them was saturated. 100% of its cycles were being used. So it was literally just the RTOS was context switching and doing its best it could to do everything, but it literally could not get the LEDs to blink at the right rate. And that should be using 1%, if that, of the processor. So what have I done to what setting did I miss? What have I done here?
And all you did was upgrade from, you said V4 to V5. That was generally the upgrade process. I mean, I guess you probably had to change a couple things that broke, but
yeah, V4 to V5, that's a whole nother blog article of pain. You finally get there, so you figure it's got to be my fault. But and then you start looking at, is it this code? And I started whittling it down to it's between this, and the only thing left was this sleep for, the C++ standard this thread sleep for. So then, if I commented that out and just did a standard FreeRTOS vtask delay, it worked fine. So I knew it had to be that, and that's when I started digging, what is going on here? Thinking that still I had some setting wrong deep in the layers, but nope, that's just the way that it was. It's the whole blog article describes what's going on, and it is an interaction between the standard C++ sleep4 implementation, which calls clib usleep, and then Espressif has their own usleep implementation that does something different, whether it's a usleep for less than a tick period versus a usleep for more than a tick period. And because of this, the result would cause some portion of your sleep to actually be busy weighted as opposed to actually yielded and gone off to do other things, to other threads. And so this is what basically why you sleep for 10 milliseconds, but you could be actually busy waiting for 9 of those milliseconds. So that would cause a lot of unnecessary CPU usage, depending on how the timing works.
Do you think you have a hunch on why there's two different implementations? Like
because when you're doing a use sleep less, and it's documented this way. If you're going to use sleep
it's documented as two separate functions.
Yeah, so if you want to use sleep for 20 microseconds, you're going to get a precise busy wait. Like if you're doing pin manipulations and you want to sleep exactly that long, you'll get it. So I think they did that for that reason, because the default tick rate is 10 milliseconds. So if they didn't do that, then you could never sleep less than that rate. But when you want to sleep for 11 or 12 or 15 milliseconds using C++, you're going to yield some portion of a tick period, and the other portion is going to be busy weighted because of the way that the C++ layer wants to be very precise about how long you're actually sleeping. So it'd call you sleep the first time, and then if you're going to delay one tick, let's say, well, that one tick is going to depend on when your next interrupt is. So it could be a nanosecond or it could be 9 milliseconds or whatever. So we do that, and then the sleep for back in the C++ land would say, well, we only actually slept for 9 out of the 10 milliseconds we wanted to. It assumes the only reason this could possibly occur is because some break signal occurred in Linux or something like that. That's not what happened here. What happened here is that usleep just returned early. So then C++ is like, we're going to sleep again to fix this. And then it ends up sleeping for less than one tick period. So then it uses the busy wait implementation instead. And so then it does that, it goes back to the C++ world. C++ is like, yes, we slept the right amount, we're good. And then you're all done.
But it halted the system while it's doing it. So, and then this is what resulted in basically the LED just blinking at an erratic rate, like all these differences.
Yeah. So I was surprised because things were sort of still working. It was still even connected to Wi-Fi and everything, but it was just like using every possible cycle at the same time. So, very, very interesting. And the big thing was that, hey, what happened between IDF 4 and IDF 5? Because it worked fine in IDF 4, and it just, libc++ changed their implementation to do that double check of a monotonic clock to make sure that they're actually sleeping the correct amount. And that's fine because sleep is never supposed to return before the specified time. Yeah, it's allowed to. You're allowed to sleep late. You're allowed to sleep extra. You're not supposed to sleep less than, according to POSIX spec at least. But so, in my analysis, it's the sleep implementation that's the problem, as opposed to the C++ lib. I think C++ lib is using, things as it should to spec. But this is either, you can take this either as, well, embedded systems are just too complicated for C++, or you can take it as Espressive did a lazy job in implementing usleep. And so one way or the other, I'm probably angering someone. But I think usleep can be fixed. I think it can be written better. And that's why I did the PR.
I was going to say, because you also, contributed back. You opened the PR with the Espressive team. And actually, we like them. They're pretty great engineers. I'll probably see a lot of them in the embedded world next week as well. So
I think overall, very happy with Espressive and the code that they ship and everything. It's great. Been very happy with a lot of their stuff. So, yeah, haven't got a lot of response yet on that. We will see. I think partly because it takes a lot of explaining how to, what's going on here, why Sleep 4 is broken, but we're trying to fix it in ulib and newlib. So it's a weird interaction, if you just look at one side in isolation, you don't see the bug. You have to see how the interaction is between the two to really see it. But as an engineer, I like it all. I like to solve things. I like the fact that in firmware engineering, you kind of get you kind of have control of the whole thing.
Everything is your fault.
everything's my fault. Yes, because especially the hardware, you can fix it in software. And well, the big thing, of course, today, right, is the radio binary blobs that you don't get the source code for, and that is the one thing we're like, we don't get that. But besides
unless
that, you can
you're
go
one
all
of the
the
10 biggest companies in the world, and then they'll give you the source, just because.
Yeah, there you go.
At Pebble, we got the source code of the Bluetopia stack from TI, which was really nice because then we found a lot of bugs in it. And I don't think we got the one from Dialog, but we were at least like able to have them on tap.
Cool. Yeah, that's very cool. Absolutely, yeah.
I don't meet a lot of engineers doing C++. And so I guess, why is your current project using C++? Did you decide that? Would you pick it again if you were doing this project again?
Oh, that's a very good question. So I joined this current product I'm working on already was sort of started and already had C++, and that was something that was sort of on my bucket list. I kind of wanted to work on that. I think if I was starting brand new, I probably would use it in a limited fashion, just use some of the things that I like to see. And because the thing about, unless every SDK that I've seen is always written in C. So unless you are writing every bit yourself from scratch, you are going to interface a tremendous amount of C code anyway. But this particular project already was using C++, and thought it was, I think there's a lot of merit to it. I think there's a lot of people who are just stuck in their old ways, who haven't really looked at to educate themselves. But I also think there is, even knowing all of that, there's still, I think, a very good reason just to keep using C. It's definitely easier to get the memory stuff correct. I mean,
in which one, C or C++?
Well,
and C, because you know exactly what you're doing. Everything is your fault,
Yes.
Got it.
As I was saying that, this can mean anything, but when I'm using C, I feel like I've gotten to the part where my mental model of what's happening on every line of code has gotten really, really good, and there's just no surprises. And using C++, there's a lot of really cool features, and you can really use them very, very well. But it's going to take a lot longer to get a mental model of what every little feature is doing. And so, I'm not a super enthusiast saying we all need to use C++. I'm sort of more of a pragmatist. And I like learning new things, so I'm still ramping up on my expertise towards C++. So, that's kind of where I'm at right now.
With using C++, given that things are more of an unknown, you have to peel back a lot of you have to open the hood to understand if you're using more memory or if you're using more CPU. Do you actually have extra data points, analytics? Are you monitoring the heap usage at all times? Are you monitoring the CPU more? I think in C, we just kind of assume we're using the minimal amount that we ever could because we know what's happening. Are you actually tracking more of this information?
Yeah, I have a build where I definitely run a live, constantly analyzing how much heap we're using. We send some basic statistics up, to the cloud, to the back end, to make sure that there's not a slow memory leak where some device is slowly walking in death march. But I have my debug builds where I'm looking live at how much heap usage is being used and making sure that we're within our tolerances. So
is it ever surprising with C++? I guess
I have not gotten a huge surprise, but that might just be because I'm already, I already have all this experience. I'm not just jumping in from, there's a lot of, I think it's awesome what ESP32 is doing because a lot of people can jump from the Arduino world, kind of hacker tinker stuff, and then they can want to jump into making a real product. And I think that's awesome. But the other side of that is a lot of people who don't have any idea of what's going on memory-wise or CPU-wise, and they start writing lower-level code. If they start writing, you may be surprised when things are using a lot of allocations. And for me, it hasn't been too surprising. But then ESP32 is just they're using the heap all over the place. I mean, their default JSON.
Behind the scenes, yeah.
Well, behind the scenes for all the radio stuff, but also their default JSON project is CJSON, which again, the code is amazing. I'm not saying anything negative about the code, but like if you make a small thing with like 5 or 6 key value pairs, every single key is a separate heap allocation, unless you try to do a pre-allocation or something like that. I did a small analysis on that. I had 32 allocations on a small package that I was putting together, and that surprised me. And that's all written in pure C.
Yeah.
So I think the surprises can come from both sides. Now, like I said, I worked in like 10, 15 years in an area where we didn't even touch malloc. You know, I had a linker wrap around. If anybody touches malloc, I'm going to hit a breakpoint.
Yeah.
Because I am not using the heap. So I've gone from there all the way over.
All the way to the other side where you can't even control it. Yeah. We, in my jobs, we've used the heap, and it's been fine. As long as we have instrumentation, as long as if we crash, we capture the heap and know it's consuming the memory. So it's totally fine, or it's fine in some ways.
Yeah, and I don't use. I try not to use the standard library for most like lists and stuff. I'll use for vector, but and there's something I don't know. Like the embedded template library is my best friend, the John Welby-Love, I think his name is. He's doing a great job of putting together a standard library replacement that uses all statically allocated stuff. So you can even statically allocate strings, but then still have those nice string operators on top of it. So
cool. Is that specifically designed for ESP32, or is that just a general C?
That's a general C++, yeah.
Oh, cool.
ETL or embedded template library. That's if you're using C++ on embedded systems, I think you should definitely be using that personally. So, and then it's cool too because they have thread safe lists and queues and stuff like that, which is standard library. It is not thread safe. So, you can do a multi-consumer, multi-producer, or single consumer, like they have very different implementations. One that will use atomics, one that will use mutexes. You get to pick your implementation that you like. You don't have to spend so much time rewriting your own stuff. So that code's great.
Got it. I have a few more general questions. Let's say people want to get people are interested in learning more about C++ with embedded, maybe on the ESP32 as well. Like, where should they go? Because you learned this, I guess you got embedded C++ experience in the last 3 years, so you're still relatively new. Any great resources you came across?
Well, the embedded template library would definitely be just one of the libraries. I don't know if so. How I've just been learning on my own a lot. CPPCon, but that's just videos, general stuff. I haven't had like a particular blog that's just been like C++ embedded. I mean, I've read a little bit of embedded artistry and some other things, but
the trial and error approach. It sounds like
trial and error. I read the docs. I've asked ChatGPT a lot of questions of and then you verify it, but it's actually been pretty good. Like, if I'm writing this function and I want to make sure that these are my 4 or 5 constraints, what are the options here? What are the trade-offs? It does a pretty good job of telling me all those things. And then I can use my 20 years of experience to say, no, I think you're wrong. I'm going to do this other way, or keep looking into those types of things. Yeah.
Yeah, and that was going to be my second question was, are you using some sort of, I guess, what is your like tech stack? Like when you have loaded, what is your debugger that you use? What IDE? What's your favorite tool set?
Yeah, I've been around and around on that too. I mean, growing up in the embedded space, like there was a time when it was very difficult to do embedded on anything else but Windows. There was just not the tooling. On some of these vendors, like they created an IDE for you that wasn't necessarily even available on other platforms and stuff like that. So I for a long time I was on Windows. I mean, I'm on Linux now, but ESP32 is interesting too because the original ESP32 doesn't always have like a debugging interface. Like it's a printf world, which I came from the debugging interface. I would step through every single line of my code, and I would step through like even like the deep libraries and everything. And that's how so right now it's a lot of logging. Hopefully in the future we'll be using more debuggers, but we'll see. So it really depends on the vendor. If I can use a like a J-Link, then I like to use that. I mean, some people scream about wanting to use open everything, and that's like a
J-Link is amazing tool.
I mean,
worth the hundreds of dollars, especially if your company can buy you one.
Plug it in, it works. RTT logging or whatever, SWO, you don't have to do these slow printfs. People just don't have a good intuition of how slow printf is. And so if I had it my way, yeah, I'd be plugging in with some kind of J-Link interface and looking at every line of code that I write. I like to step through everything and see how things are actually working. And as far as like the IDE, I'm in VS Code right now. That works very fine for me. More of a pragmatist there too. I don't need to be, as long as it works well enough. So that works well enough for me right now. Dev containers, I love dev containers for all of their, standardizing the environment, making sure everything builds correctly, and then reproducing it in your pipelines and all that kind of stuff. I think that's a really big deal. Of course, once again, embedded is difficult with containers because I need a UART connection, or I need a debugging connection.
USB into containers or VMs is also a challenge. Different on every platform too, especially Linux.
Yeah. So it's like, once again, it's embedded is on the outskirts or whatever. You have to do it a little bit of extra work, but I think it's worth it. Yeah.
Got it. I think we only have one more minute. How was your experience writing an interrupt post for people considering, writing about their favorite bug that they ran into recently?
Oh, it was great. I really found it to be fun. I enjoyed writing it, and then the process of working through with the team and everything. It was super, super great. A little bit of feedback, and everybody was great. So it was a nice little surprise to see that there was a little bit of traction on it, and doing a live with you was also kind of a fun little surprise. And I definitely encourage it, because I think it's good. I think it's good to have some community and share some of this knowledge, because like some of those posts that you guys have on there that dig into like printf or the zero to main kind of stuff, a lot of that stuff I put together in my own little notes or whatever, but then just to see it all laid out, it's great.
Yeah, I wish we shared more in the firmware space. It seems to be one of the places that least share, I would say.
Probably.
So yeah, thank you for the post. Thank you for the chat. This was great, Steve. And
thank you.
I think we're about to sign off. So have a good one, Steve.
All right, thank you. Take care.